Hello, today's lesson is 1.11 Applications of Pythagorean Theorem. You'll need your math notebook, pencil, and calculator. Please make sure you're taking notes and working the problems as we go through this lesson. We'll go ahead and get started. So our essential question is, how do I use the Pythagorean Theorem to find the length of a missing side of a triangle? I will be able to use the Pythagorean theorem to find the length of the third side of any right triangle when given the lengths of the other two sides, so that I can determine the missing length of a right triangle. I'll know I got it if I can analyze the information to find missing lengths of right triangles by using the Pythagorean theorem. So remember this, we've already gone over this, we modeled it. We've done some practice problems in previous lessons. So we've got the theorem is a squared plus b squared is equal to c squared. And c is always the hypotenuse. It's always across from that right angle, and it's always the longest side. All right, so we'll just jump right into some practice problems that are real world situations. So it says Callie has a 6-meter ladder that she wants to use to get her cat out of the tree. She puts the base of the ladder 2 meters away from the base of the tree. How high into the tree will the ladder reach? So here's the ladder, 6 meters. Here is the distance from the tree. This is our tree. So what we have to try to find is this length here. Now notice where your right angle is. So this is your hypotenuse. So we'll go ahead and you need to write the formula. A squared plus b squared is equal to c squared. So a, we can use just what we're trying to find, a squared. And we'll use 2 for b. Remember, it doesn't matter which one's a or b, as long as this is one of the legs. And then we'll have 6 squared. So we'll go ahead and do our math. 2 squared is 4. 6 squared is 36. We're going to isolate that variable, so we're going to subtract 4 from both sides. And we get a squared is equal to 32. So a will be the square root of 32. We're going to use our calculator and we're going to round the answer to the nearest tenth. So remember second, x squared, 32, and it comes out to 5.65. So let me just write that up on the board, because you have to make sure you are rounding correctly. So it's approximately 5.65, but it does say to round to the nearest tenth. So we look at, here's the 6 is in the tens place. This 5 tells you to round this up to 7. So the answer would be 5.7. Next one. A wheelchair ramp is constructed to rise 1 foot off the ground and extends 13 feet along the ground. How long will the wheelchair ramp be? So it's good to draw a picture. So if you think of a wheelchair ramp, this right here, the rise would only be 1 foot. So we're going to go, it can't be too steep, that'd be crazy to be a steep ramp. So it says 1 foot off the ground. So that's this 1. And then the ramp extends 13 feet along the ground. So this is our ramp. So you have to make sure you can label it correctly and you know which side is the hypotenuse. This forms the right angle. So 13 would be our hypotenuse. So we're going to do a squared plus b squared is equal to c squared. We'll just find a. We're going to use 1 for b, and then we have 13 squared. So we're going to go ahead and Simplify. 1 squared is 1. 13 squared is 169. We need to isolate the variable, so subtract 1. And we get a squared is equal to 168. So a will be the square root of 168. And we're just going to assume that we have to, again, round it to the nearest tenth. So we'll do the second x squared, 168. Oops, I put the wrong thing in. Second x squared, 168. And it comes out to 12.96. Ooh, so we got to be careful in the rounding here. So it's approximately 12.96. Now, the 9 is in the tens place. This 6 tells us to bump that up, which is actually going to make it 13.0. So make sure you understand the rounding part when you round your answers. Our next one, Alex attaches a diagonal brace to a rectangular shaped picture frame. If the dimensions of the frame are 33 inches and 44 inches, what is the length of the brace? So we have a rectangular shaped picture frame. So let's start with drawing a rectangle. There's our picture frame. And then it says he puts a diagonal brace. So let's put that brace in here. Diagonal brace, that's what it would look like. And we know that the frame is 33 inches and 44 inches. So we'll go ahead and label that. This is 33, 44. Here's our right angle. So we are looking for the length of the brace, which is our hypotenuse. A squared plus b squared is equal to c squared. So we're going to do 33 squared. These are going to be some big numbers. 44 squared is equal to c squared. All right, get those calculators out. So do 33 squared. It is 1,089. And then we're going to do 44 squared. Oops, I did the wrong button. Always check your display. 1,936. And then we need to go ahead and add those two together. Make sure you are working this out with me. So we're going to add 1,089. And it comes out to 3,025. And that's c squared. 3,025. So c will be the square root of that. Oh, sorry, don't need a 2 there. Getting a little carried away here. That's what c is. So use your calculators and do the square root, second x squared, 3,025. And it's actually 55. Isn't that great? Came out to an even number. So this is 55. No rounding needed. All right, last one. A rescue boat leaves Walk Dock and travels 18 miles due north to haul in a sailing vessel stranded in the middle of a lake. After attaching a cable, the rescue boat hauls the sailing vessel 80 miles due east to Blue Haven Dock. Determine the direct distance from Walker Dock to Blue Haven. Okay, so we're going to start with our points here. So we're going to have, we start with Walk Dock here. You always want to draw a picture to help visualize. Now it says it travels 18 miles due north. So we're going to go north, that's up. make it a little bit longer. And this is where the sailing vessel is stranded. This is 18. This is where our sailing vessel is. I'll just put vessel. No need to put sailing. Our vessel. And then it says that after attaching a cable, the rescue boat hauls the sailing vessel 80 miles due east. So that's going to be this direction to Blue Haven Dock. I don't know. I mean, we'll just put it right here. It's not accurate with the number or the distance, but yeah, we'll have the numbers. And so this is Blue Haven Dock. I'll just put Blue Haven. And this was 80. So the question is determine the direct distance from Walker Dock to Blue Haven. So the distance here. So let's just change the color. There we go. So here's this is our right angle here. So what we're looking for here, that distance will be our hypotenuse. Start with the formula, a squared plus b squared is equal to c squared. We're going to do 18 squared plus 80 squared is equal to c squared. All right, let's use those calculators. So 18 squared, hit the wrong button again, is 324. And then 6,400 is 680 squared. So this was 324, 6,400. Add those two together and you get 6,724 is c squared. So c will be the square root of that. So let's go ahead and use the calculator and do the square root of 6,724 comes out to, I can't see my display very well. I think it's 82, sorry. Yep, 82, which makes sense because it needs to be the longest side. So this is 82. All right, so please make sure that you complete your OMS lessons, go through them thoroughly, take notes, work those problems out.